do need to record. I had someone absent in first block, so we need to record. Right. Okay. So, like I said, we're going to kind of revisit a topic from Algebra 2, so hopefully as we go through it, it will come back to you, and we'll have us an easy lesson today of just trying to remember some Algebra 2. Alright, so the reason we're having to revisit some Algebra 2 is because we're going to have to use this skill in the next lesson that we do on Thursday. So we're having to review something today. Okay, so it's setting us up for something else new on Thursday. Alright, I have one correction that we need to make. This very first line where this 7 is, we're going to make it a 6. So change that to a 6. Alright, so we're going to be dealing with polynomials, and specifically we're going to get to dividing polynomials today. But first of all, we're going to do something even easier, and we're going to add, subtract, multiply these two polynomials that I have given you. So you have p of x and you have q of x, and the first thing I want to do is add p of x plus q of x. So what does that involve?
Combine like terms.
Yeah, that's it. As simple as that. So I think we can probably do that without recopying these. And let's put our answer in descending order, which means the highest exponent first. So I would have a 6x squared. I have a negative 4x plus negative 2x is negative 6x. And then I have a 1 plus 6, which is 7. Okay, p minus q. Alright, so that I don't make a mistake, I'm going to recopy p. Subtract, bring down q. Are the parentheses necessary?
Yes. Yes. Yes.
Yes.
They are
The
necessary.
second ones are. First one's no. These, yes, because I'm subtracting more than one term, so those parentheses are important so that we remember to distribute that negative. Okay, so that gives me 6x squared minus 4x plus 1 plus 2x minus 6. And then I do have a little bit that can be combined there. So I will have 6x squared minus 2x minus 5. Are we good there? Okay, so now p of x times q of x. So I'm just going to take that 6x squared minus 4x plus 1 and multiply it by negative 2x plus 6. Okay, so that's just going to be a lot of distributive property, right? So I'm going to take the 6x squared, multiply by both, the negative 4x, multiply by both, 1, multiply by both, look for like terms. Okay, you do it, I'll do it, and we'll compare. Okay? Okay, when you get an answer, check up here and make sure I didn't make a mistake. Thumbs up. Any questions on that one? Okay, so let's go back up to this question that I asked. Which of these are commutative? What does that mean? You can switch the order and get the same thing. Okay, so with addition, if I added q plus p, would I get the same answer?
Yes.
Sure. So that one is commutative. Subtraction. Would q minus p be the same thing? Not usually. I mean, occasionally you'll get the same thing, but as a general rule, no. And then what about multiplication? Would Q times P give me the same answer? Yes. Okay, so two of those, addition and multiplication, would be commutative, but not so much with subtraction. Is division commutative? No. Again, occasionally you would say, what if I divided x by x? Then it doesn't matter if I switch it, right? But generally speaking, division is not commutative. Okay, so we're going to go back. Last block we decided that this was probably 4th grade math. And we're going to use long division to divide 2,273 by 5. It's probably been that long since you did it. All right. So, which one is the divisor and which is the dividend?
The divisor is 5.
Divisor is 5. And then the dividend is 2273, and I can't answer the rest yet until I do some division. Okay, so I know this seems super elementary, but it's important because we're going to have to use these same steps in a minute with polynomials. What is the first thing I do?
Multiply.
22 divided by 5.
You're jumping ahead one step. I'll come back to you, Baden. What?
22 divided by 5.
Yes. Okay, so technically, guys, I'll look at the 2, and I'll say, does 5 go into 2? No. So I go back and pick up the next digit. 22 divided by 5 is what? Or how many times does 5 go into it? 4. What do I do with the 4?
You put it on the top.
Put it on the top. Okay, now, Baden, what do I do with the 4? Multiply it by the 5. Okay, so I take this thing I put up here, and I multiply by the 5, and I get 20, and where does the 20 go? Below the 22. Okay, guys, we make so many mistakes when we subtract, so we're going to be careful, especially when we get to the polynomials. 22 minus 20 is? 2. Okay, 5 doesn't go into 2, so I do what? Bring down the 7. And I start the whole process again. 27 divided by 5, 5 times, 5 goes up top, 5 times 5 is 25, subtract, that gives me 2. I still have one more number up there, so I bring it down, and then I start all over again. 23 divided by 5 goes 4 times. 5 times 4 is 20. I subtract, and I get 3. Okay, what do I call 3? The remainder. Okay, how else can I write this remainder of 3? Like, how can I incorporate it into my answer? I can make it a decimal or a fraction. Okay, so I could write my answer 454 and 3/5. I would put that remainder over the divisor, which is what we'll do in a minute. Or, of course, we do know that that's 454.6. So we'd get the 0.6 if we put a decimal here, add some zeros, and keep going. Okay? All right, so it's been a really long time probably since you did that. What's my quotient then?
0.6.
454.
The 454, my remainder is 3. Is 5 a factor of 2273?
No.
No. How do I know?
Because it's a decimal. It doesn't go to...
Didn't divide evenly. So if I have a remainder other than 0, that tells me it doesn't divide evenly. That tells me it's not a factor. Okay? Any questions on that baby 4th grade problem? All right, so now what we're going to do is take that same exact process and apply it to dividing polynomials. So we're going to take the 2 up at the very top of the page, our P and Q up there, and we're going to divide P by Q. Okay, so we're going to have our little long division sign again. 6x squared minus 4x plus 1, and I'm dividing it by negative 2x plus 6. Okay, so we set it up just like that little baby problem above. And we attack it the same exact way. I look at the first term, and I divide it by this first term. So what is 6x squared divided by negative 2x?
Negative 3x.
Negative 3x goes up on top, just like the 4 went up top. Then we took that 4 and we multiplied it by the divisor. I'm going to do the same thing. I'm going to multiply this negative 3x by the entire divisor. So that's 6x squared minus 18x. Okay, but here's the part where we will make dumb mistakes. I have to subtract all of that from the line above. Okay, so 6x squared minus 6x squared, that's 0. If that first term is not 0, then you've made a mistake. Okay, those should cancel out. That's why we chose the negative 3x, so it would cancel out. But what is negative 4 minus negative 18? Positive 14x. Bring down the next term, just like we brought down the next digit in the example above. And then I start all over again. So I take 14x divided by negative 2x. What is that? Negative 7. Minus 7 goes up top. And then we multiply negative 7 times the divisor. That's 14x minus 42. But I'm going to subtract it. Okay, 14x minus 14x should be 0, and it is. What is 1 minus negative 42? 43 is my remainder. I know when I get to the remainder because there's no more terms. There are no more terms to bring down. Okay, so how would I write this answer? Negative 3x minus 7. This was a positive 43, so I'm going to say plus 43 over the divisor. Was it a factor? No, it didn't divide evenly. There was not a remainder of 0. Okay, is there a question back here how we got the 14x? No? Thought there was some confusion on that. Okay. All right, just be super careful when you're subtracting. Don't be afraid to use that calculator to double check your subtraction. Alrighty, next talking up. Alright, we're going to set up long division yet again. So, let's put our 3x plus 2 out here. Okay, what do you notice? First of all, I do want to write it in descending order, which it is already in. 6x cubed minus 5x squared, but how many x's do I have?
What? 2?
None. No x's here. So fill in a 0.
Oh.
Because if you don't, then you won't have an x to subtract from. So if a term is skipped, fill it in with a 0. And that goes for the constant too. If there's not a constant, tack a little plus 0 on the end. Okay, now we're starting the whole process. 6x cubed divided by 3x. 2x squared. Put it up top. Take my 2x squared, multiply by the entire divisor. I get 6x cubed plus 4x squared. And I am subtracting. Okay, what is that difference?
Negative 9x squared.
Where'd I get the 4x squared? Okay, so I took, you're okay with the 2x squared being here? So I'm going to take that times the 3x and that times the 2. Now I'm subtracting, and I get what?
Negative 9x.
Negative 9x squared. Bring down the next term, which is a 0. And start all over again. What is negative 9x squared divided by 3x? Negative 3x. Okay, the negative 3x multiplies by both of these, and I get negative 9x squared minus 6x. Now you can see why the 0 needs to be there, So if I didn't have the 0 there, I might accidentally get that 3 in there and subtract things that are not like terms. Okay, so what is 0 minus negative 6?
Negative 6.
6x. Bring down the 3. And one last time, what is 6x divided by 3? 2. It's a positive 2, so I do plus 2. Multiply the 2 by each of those. I get a 6x plus 4. And I subtract, and I get what?
1.
Negative 7.
Shoot. Sorry, I'm out of it right now.
We always make so many more mistakes when we subtract rather than add, don't we? Or I do. Okay, so my answer would be 2x squared minus 3x plus 2 minus 7 over 3x plus 2. Question. Do you remember doing that in Algebra 2 now? Ooh, I see some no's.
I do.
Okay.
I think I was confused.
All right. So this one, I'm going to let you do on your own. I will do it up here also, but I'm not going to talk through it. Okay? All right. So talk with a neighbor or compare with a neighbor if you want to. But you know, there's so many of us, so just keep it low. Yes. We'll do synthetic. Synthetic won't work with all of them, but it will work with some.
All my life.
Don't be afraid to use that calculator if you need help subtracting. I'd rather you use it than miss it. Okay, I'll walk around. If you have questions, stop me.
No, 3 plus 4, this should be 7x. You want to stop here. I know what to do. This should be 7. So it should divide evenly everything. 2x, 7. Which was 7? Wait, never mind. Okay.
Are we on this side of the room?
Okay, so I got 2 perfect. Okay, so 2 right there.
Now we're going to subtract that line.
Okay, so this is 2x. This number will always equal this. Do you see what to accept this one?
Alright. Okay. No. She said she put millions for Halloween.
This turns into a plus sign. So I'll make it 7 minus.
So it's 7. Yes. Just plus 7. And then I don't carry that down, right?
Stop.
7x here, but then you have to repeat it. How many times is x going to 7?
How many times can 7 go to x?
Seven.
The second thing.
That's a perfect 2 though.
7 so all this will cancel out. So that's right too.
No remainders. All my life. All my life.
I'd rather do equal if I hate it.
Izzy, what's your name?
questions on this one? Shh. Fun's away, fun's away. Playtime's over.
Playtime on the big league.
All right. So, in certain situations, there is a shorter method that we call synthetic division. So it is definitely a shortcut, and what I like about it is we use addition instead of subtraction, which means we make fewer mistakes. Okay, so this doesn't work in every single problem. It works when the divisor, we know what that means, is x minus c, or it could also be x plus c. But what has to happen is you have to have just an x and a coefficient of 1 in front of that x. Okay, so glancing back up here, this synthetic that I'm about to show you would not work on example 3 because that's a 3x plus 2. It will work on this one because it's x minus 2. It would not work on this one because it's negative 2x in front of it, negative 2 in front of the x. Okay, bless you. All right, so what we're going to do is set up this one that I said will work. I'm going to set it up and show you that and see if that comes back to you. Okay, so what I'm going to do is take the c value. So if this is an x minus 2, what is being subtracted from x? A 2. Or think of it as I'm going to take the opposite of this sign. So if you think of minus 2 as being a negative 2, then the opposite is a positive 2. That number is going in this little, it's sort of a half box. So if this was x plus 2, I would put a negative 2 here. So I'm taking the opposite sign, which is why I'm going to add in a minute. So I'm eliminating subtraction, but multiplying this number by a negative to compensate for that subtraction. Okay, so put the opposite there. And then I list in descending orders the coefficients and constants, no variables. So it doesn't get bogged down in the variables. I have 2x squared, I had a 3x, and a negative 14. No variables used in synthetic. Leave a line for another row of numbers and draw a line. The first one comes down. And then we start a process of multiplying this by the number in the box, putting it in the next column, and adding. And then we do it again. This number times the number in the box goes in the next column, and we add. Now, what is the significance of 2, 7, and 0 in this problem?
2 is the exponent, 7 is the constant, and 2 is the remainder.
There we go. So it's your little coded answer here. This is always the remainder. This is your constant. And then that would be my x coefficient. If I had another number, it would be the x squared. If I had another one, it'd be x cubed. Now, doesn't it make sense that if I divided x squared by an x, I should only have an x? Right? So then we have to put that in context. This is 2x plus 7 because it's a positive 7, and no remainder. So there we go. Faster. But, again, it won't work on every single one of them. If this coefficient is not 1, or what if I divided by x squared plus 2? I can't use synthetic. So it has to be just an x plus or minus a number. Okay? All right, so here's another one that we can do it on. So I'm going to use synthetic. What number will go in my little box? Negative 2. Set that one up. Okay, now notice that this is all jumbled. So I'm going to rewrite it in descending order up here so that I don't miss a term when I set everything up. Oh, look, x squared is missing.
Oh, 0
Right,
x
0
squared.
x squared.
Put that 0 in there. Then my negative 2x, then my 18. Okay, so I rearranged it, descending order, account for any skipped terms with a 0. Now let's bring our numbers down. 1x to the 4, 4x cubed, 0x squared, negative 2x, and 18.
Let's do this.
Leave a row for numbers. Bring the first one down. Multiply. Negative 2. Add 2. Multiply. Negative 4. Add negative 4. Multiply. 8. Add 6. Multiply. Negative 12. Add 6. And you're done when you're out of columns. Any question on those numbers? Did I make a mistake?
No, you didn't make no mistakes.
I wouldn't guarantee it.
Oh.
Those who've had me know I make my fair
That's
share.
what I got, Miss Campbell.
Okay.
That's what I got, Miss Campbell.
All right, remainder. Don't forget that is your remainder. Constant. X squared, x cubed. Keep going until you run out of numbers. And so my answer is x cubed plus 2x squared minus 4x plus 6. That's a positive remainder, so plus 6 over x plus 2.
Oh my goodness.
Question.
Don't make it.
Good. Okay, yes.
So is there always a remainder like this?
Sometimes it'll be a 0, like back here. But that last number always represents the remainder. Okay? All right, so you're going to use your method of choice on this one. Raise your hand if you want to use long division. Wow, okay. You go for it. Since the majority, I'll do it both ways. Do it both ways. Okay, on your mark, set, go.
But I can get this one out and get better.
Make sure it's in descending order. What is that ticking sound? Do y'all hear it?
But it's very.
What is it?
I think it's in there too.
Usually it's very easy.
It's like bouncing off this wall or something. Not one soul was brave enough to do long division last block.
But we have Billy Camp in here.
I'm also doing long.
Yeah, there were quite a few that raised their hand for long division.
You got Billy Camp and Billy Owens. Yeah, but you know what I do?
This came on.
Okay?
Shoot, Bronwyn.
I had synthetic though, so.
I'm not surprised
You're not surprised that I did synthetic?
that you beat me.
She said she's not surprised that I beat her.
No, she's not surprised that you beat me.
I beat everyone in the whole class, in the whole world.
In the whole world.
Yeah.
It's just Roman against the world for real.
So,
Bronwyn, let's play pool today.
why are you being so weird?
Y'all-
I have a volleyball game. Wait. Wait, no, my volleyball game's at like, I'll get, we literally won't like, that's scary.
Or your volleyball game.
I leave the school at 3:30.
Can we do the concert for 10 minutes?
Let's just check out of school, buddy. Let's just check out of school.
All right, both methods.
If you found out that me and Carson checked out of school to go play pool, would you be mad?
Oh, I'd write you. You go to the big house.
What if they checked out?
All right. Who has a question on either method?
What's your question?
None? Hi, good job, good job. Okay, example 8. I have set up a problem for you, and you are going to figure out what the original problem was.
I like this. No.
So see if you can work backwards and tell me what the original problem was. What was I dividing into, and what did I divide by?
Can you?
Austin, you got this?
We'll finish in about 2 seconds.
Yeah, where you got it?
I'm not sure you divided it. Because you just did opposite. So we'll that
Divide by it there for you.
Oh, and that's always the opposite.
All right. Shh. For an easy question, what was I dividing by?
1.
X minus 1. Okay. So what was I? Shh. What was I dividing into? Negative 9x to the 4 plus 10x cubed plus 7x squared. No x, so you can put a 0x if you want, but I'm going to skip it and just put minus 6 divided by x minus 1. And then my answer was, I'll just put equals negative 9x cubed plus x squared plus 8x plus 8 plus 2 over x minus 1. Question.
Good.
All right. Next, last example. Okay. Find the value of m so that the remainder of x cubed plus 3x squared minus mx minus 24 divided by x plus 3 is 0. Okay, can I set up synthetic division on this?
No. Yes.
Yes. Okay, what number goes in the little
Negative 3.
little shelf, I guess we might call it. Okay? Now, let's set up everything else. Our 1, our 3, negative m, and negative 24. Okay, who has a question? Because that is our coefficient. And that's what we're going to try to figure out. What is m?
Wait, so
We're finding m. Now, I know that 1 will come down. And if the remainder is 0, what do I do with that information?
Move it to the curve.
This is 0 under the 24.
0 under here. Now, we're going to work, I think you could probably work backwards or forwards on this. Let's just start at the beginning. So, negative 3 times 1 is?
Negative 3.
Put that in the next column, and I add, and I get 0. Negative 3 times 0, put that product in the next column. What's negative m plus 0? Negative m. What is negative 3 times negative m? Positive 3m. Okay, so now how does that help me? Well, this right here tells me that negative 24 plus 3m has to be 0. Right? If I add those two quantities, I have to get 0. So that's a little baby equation. Let's solve that equation. I'm going to add 24 to both sides and divide by 3, and m has to be 8. Cool.
How did you know that there was a remainder of 0?
Because it said so that the remainder is 0.
So you just
Yep. Any other questions there?
No, ma'am.
Okay. All right. Shh. Listen up, guys. We're going to take a small restroom